So every programmer, sooner or later, hits a couple of big walls. You've got these massive files that just seem to go on forever, and then you've got those totally unexpected errors that just crash everything. In this explainer, we're going to break down how to conquer both and really turn you into a more confident, more resilient coder. Let's dive in. Okay, so picture this, because it's a classic problem you're going to run into all the time. Imagine a huge data set. Maybe it's sales logs, maybe it's scientific data. Your program has to read every single line, but there's no little note at the top telling you when to stop. So how do you build a loop that just, well, knows when the file is done? And this really gets to the heart of the first problem. Trying to load a massive file into your computer's memory all at once? That's a recipe for disaster. It's super inefficient and can totally crash your system. We need a smarter way, a way to process it piece by piece or line by line without needing to know the total size up front. All right, so how do we actually do this? Well, there are a couple of ways to tackle it. There's the kind of old school, more manual approach using a while loop, but then there's the more modern, more Pythonic way using a for loop. And as you're about to see, it's just so much more elegant. And here's the thing with this while loop logic. See that repetition? You have to read a line at step 2 before the loop even starts. Then you have to remember to do it again at step 5, deep inside the loop. It works, sure, but it's clumsy, and it makes it way too easy to forget that second read and accidentally create an infinite loop. Not good. Okay, so that was the clunky way. Now let's check out a much cleaner solution. This is really where a language like Python just shines. Instead of all that manual work, we can just let a for loop do all the heavy lifting for us. And boom, just look at the difference. It's so much simpler, right? The for loop is smart enough to automatically grab one line at a time, let you do your thing with it, and then it just moves on to the next. And when it hits the end, it stops. Perfectly. No double reading, no manual checks needed. It's clean, concise, and way less prone to errors. Okay, so as we're talking about processing these files, let's get a couple of key terms down. First up, record. Each line, or maybe a group of lines in your file, often represents one record. The best way to think of it is like a digital index card for a single customer or a single product. It holds all the related info for that one item. And sticking with that index card analogy, if the whole card is a record, then each little piece of info on it, like the customer's name or their age or their city, that's called a field. So a record is just made up of a bunch of fields. Simple as that. Awesome. So you're looping through your millions of lines. You're a total pro. But then, somewhere around line 500,000, there's a typo in the data, a piece of text where a number should be. Your program tries to process it, and then, bam, your program just dies. Everything grinds to a halt. So what do we do about that? Well, that sudden crash, that's what we call an exception. It's an error that doesn't pop up when you're writing the code, but while it's actually running. And by default, its only job is to stop your entire program dead in its tracks. I'm sure you've seen this before, right? This big, scary-looking block of text. It's called a traceback. And while it looks super intimidating, it's actually your friend. It's an error report that tells you exactly what went wrong and where. In this case, we have a value error. The program just couldn't turn the word test into a number. Makes sense. Look. You can be the most careful coder on the planet, but some things are just totally out of your control. Your program might try to open a file that somebody deleted, or a user might type their name where their age should go. These things are going to happen, they will cause exceptions, and you need a game plan for when they do. And lucky for us, there's a tool built specifically for this. That plan, that solution, is called an exception handler. It's a structure designed to deal with these runtime surprises without bringing your whole world crashing down. The best way to think about this is like a safety net for your code. Seriously, you basically tell Python, hey, I want you to try running this piece of code, but it's a little risky. If something goes wrong, the except part of your safety net catches the fall and lets your program handle it gracefully and just keep on going. And the basic structure is super simple. It's just 2 parts. You put the code that might break, like converting that user input to a number, inside the try block. Then right after it, you write an except block that says, okay, if that thing in the try block failed, here's what I want you to do instead. And what's really cool is you can get super specific. You can have one except block just for a value error and a totally different one for a file not found error, and so on. This lets you handle different kinds of problems in different ways. You can have a general catch-all accept, but trust me, being specific is almost always the way to go. It gives you so much more control. Okay, so try and accept are the foundation, but what if I told you Python gives us even more control over this whole safety net? There are two more optional parts we can add. First up, we have the else clause. Think of this as your success block. The code you put inside the else block will only run if the try block completed perfectly without a single error. It's a really clean way to separate your main logic from your error handling logic. And then there's the finally clause. This thing is like the ultimate cleanup crew. The code you stick in here is guaranteed to run, no matter what. It doesn't care if the try block worked or if an accept block was triggered. It just runs. This is perfect for stuff you absolutely have to do, like closing a file. So when you put it all together, you get this incredibly robust game plan. First, you try the risky code. If an error happens, accept catches it. If everything goes smoothly, else runs your success code. And no matter what, finally comes in at the end to clean up. You've literally planned for every possibility. And just look at the difference this makes in practice. On the left, one little piece of bad data and the whole application just crashes. But on the right, we wrap it in a try accept, and instead of a crash, we can just print a friendly message, and the program keeps on chugging along. I mean, that's a huge difference. That is powerful. And let's be super clear about this. What happens if you don't handle an exception? Well, either the error happens outside of a try block, or you don't have an accept clause that matches that specific type of error. In both of those cases, the result is exactly the same. Your program halts, it crashes. And that's why these handlers are so critical. So what does this all mean? The big takeaway here is that by mastering these two things, using elegant for loops for endless files, and building a try-accept safety net for errors, you've basically leveled up as a coder. You're not just writing code that works when everything's perfect. You're building robust programs that can handle the messy reality of real-world data. But honestly, this is just the start of thinking like a defensive programmer. Your code is way safer now, for sure. But it gets you thinking, right? What about other what-ifs? What if a network connection drops? What if you run out of memory? The journey to truly bulletproof code is all about asking that one simple question over and over. What else could possibly go wrong? And then preparing for it.